Containers isolate applications inside hosts, but are they secure? Let's see some of the container security best practices. In short, containers can be exploited and their isolation broken. A weakness in containers can let an attacker do a lot of harm. All the tips we'll provide in a second will aim at two major goals: reduce the attack surface and decrease potential weaknesses, and detect and prevent vulnerabilities as early as possible. It's easier and faster that way. Let's start at the source, better at the code. You build container images using Docker files or container files. These are a couple of best practices to follow when writing a Docker file. Avoid at all costs running containers as root, and instead use a low privilege user. Use minimal images to reduce the attack surface, like Destrolus. To build complex images, you should use multi-stage builds. Do not expose unnecessary ports. Use base images with the latest security patches and keep them up to date. After your code is ready, the next step is your CI/CD automation. Every new commit should trigger automated tests, not only to check for bugs in the code, but also to prevent misconfigurations. For example, an automated tool could use policies to prevent usage of secrets like passwords, API tokens, keys in the container images. You should also check for vulnerabilities in all the dependencies. The major programming languages offer tools that can gather vulnerability data on the libraries your code depends on and generate a report. Finally, after building a solid container image, you should sign it before uploading it to a registry. Image signing guarantees that you will be able to verify at runtime that the container images you're running have not been tampered with. Once you upload your container images in a public or private registry, you should have automation in place to continuously scan the images for known vulnerabilities. It is important to scan them frequently in order to be alerted of new vulnerabilities. If you run your images in an orchestrator like Kubernetes or Cloud Foundry, you should take extra care in its configuration. As a general rule, adhere to the least privilege principle and use service accounts with limited capabilities. Use policies to precisely define what should be able to run in your environments and enforce those policies with automated tools. In Kubernetes, admission controllers can prevent the execution of misconfigured and non-compliant containers. The job's not over after deployment in production. Drift from a secure posture, newly discovered vulnerabilities, and evolving threats expose your environment to risk. Keep your runtime updated with timely security patches and check your environments against the latest security benchmarks. Even if you follow all the best practices starting from the code phase, your workloads may have a vulnerability that is not yet known. That's why you need continuous scanning at runtime to act as soon as vulnerabilities are discovered. And to get anything you missed, as a last line of defense, you need threat detection tools. Threat detection tools should alert on malicious activities, like opening a shell in an internet-facing container, and block attacks with automated actions, like killing a container or preventing executables that were not in the original container from running. These are only a few security best practices when dealing with containers in the cloud. Want to know more? We have lots of great articles on our blog that can help you secure your containers. And don't forget to like this video and subscribe to our channel. Thanks for watching.